When we look up at the night sky, we often feel small. The stars seem distant, unreachable, burning in a vast silence. But what if that feeling of awe isn't because we are separate, but because we are connected? What if the stars are not above us, but within us? Every atom in your body, your bones, your heart, your breath, was forged in the heart of ancient stars. Billions of years ago, long before Earth existed, supernovae exploded across the galaxy, scattering the ingredients of life. And somehow, some of that stardust found its way into you. Carl Sagan once said, "We are made of star stuff." It's not just poetic, it's scientifically true. The iron in your blood, the calcium in your teeth, the oxygen you breathe, all born from cosmic fire. You are not a visitor in this universe. You are evidence that it works. So, what makes us human? Is it our mind? Our emotions? Our need to search, to question, to dream? Or is it something deeper, the knowledge that we carry the memory of stars in our very being? From stardust came life. From life came thought. From thought came wonder. And now, here we are. A way for the universe to gaze back at itself. Maybe that's what makes us human. At the very beginning, there was nothing. No stars. No time. No space. And then, in less than a heartbeat, everything began. Not with fire or sound, but with a blinding expansion of energy and possibility. This was the Big Bang. Not an explosion in space, but the sudden appearance of space itself. From this unimaginable heat and pressure, the first building blocks of our cosmos were born. Tiny particles collided and merged, forming the lightest elements, hydrogen and helium. They were simple, just 1 or 2 protons, but they held the power to shape galaxies. But where are the heavier elements, the ones our bodies are made of? They came much later. The early universe was too hot, too simple for complexity. Carbon, oxygen, iron, the seeds of life, had to wait for something more violent, more creative. As the universe expanded, it cooled. Gravity began to pull together the scattered clouds of hydrogen. In the heart of these clouds, pressure grew. Temperatures soared. And then, for the first time, a star was born. A cosmic lighthouse ignited in the dark. These first stars were massive and short-lived. They burned hot and fast, fusing hydrogen into helium, and later into carbon, oxygen, and heavier elements in their cores. They were the original forges, factories of matter. And when they died in titanic explosions, they seeded the cosmos with stardust, the ingredients for planets and people. The story of the universe begins not with us, but with light, with pressure, fusion, and destruction, and with the quiet truth that everything we are was once forged in fire we will never touch. Stars are not just lights in the sky, they are ancient furnaces. Each star is a slow-burning machine, fusing lighter elements into heavier ones deep in its core. Small stars live quietly, but massive ones build toward a dramatic finale. When a massive star exhausts its nuclear fuel, gravity wins. Its core collapses in a fraction of a second, igniting a powerful explosion, a supernova. This moment is so violent that it can briefly outshine an entire galaxy. But more importantly, it creates something new, the elements we need for life. Carbon, the foundation of life. Oxygen, the air we breathe. And the blood in our veins. These are not leftovers of Earth, but gifts from dead stars. They were forged in the last breath of a dying giant, scattered across galaxies, and recycled into planets, oceans, trees, and people. Without dying stars, we wouldn't be here. Every atom of calcium in your bones, every bit of gold on your finger, it all came from the heart of a star that lived and died long before Earth even existed. It's estimated that about 93% of the mass in your body originated in stars. You are not separate from the cosmos. You are the cosmos, made conscious. A temporary form taken by ancient matter on its journey through space and time. From chaos, beauty. From death, creation. The death of a star becomes the beginning of everything else. Supernovae do not mark ends, they are acts of cosmic generosity. Before life, before cells, before even planets, there was chemistry. Out in the vast, silent stretches of space, atoms forged in stars began to combine. Not in laboratories, not in oceans, but in the cold darkness between the stars. Here, in interstellar clouds of gas and dust, the first molecules were born. Hydrogen embraced oxygen, forming water, even before the Earth existed. Chains of carbon linked with nitrogen, forming the basis of amino acids. These were not yet alive, but they carried the potential of life. And then, through the chaos of collisions and the calm of time, these molecules found their way to young planets, hitching rides on icy comets, on ancient meteorites. We found them still frozen in the remnants of these messengers from space, water, amino acids, even complex organic compounds, delivered like seeds across the galaxy. This chemistry is not random. It is the quiet architecture behind biology. Molecules are not just combinations of atoms. They are structures capable of memory, of reaction, of replication. In this way, lifeless matter learns to build the scaffolding of life. The stars gave us atoms, but it was the chemistry between them that gave us the possibility to become. Amid billions of planets in our galaxy, Earth is unusual. Not the biggest, not the oldest. But somehow, the conditions align just right. The right distance from the sun, not too hot, not too cold. A stable atmosphere. A protective magnetic field. A surface where liquid water could flow. But where did that water come from? Some say it was always here, hidden in minerals. Others believe icy comets brought it in the early days, bombarding the young Earth like cosmic couriers of life's raw materials. Our planet danced with fire and storm. Volcanoes roared, lightning split the sky, and oceans simmered under alien suns. From this chaos, a miracle stirred. The sun, steady and generous, provided energy without burning us alive. The atmosphere wrapped us in a breathable blanket, and the magnetic field born from Earth's molten heart shielded us from solar radiation that would have stripped our world bare. Somewhere in this swirling mix of heat, minerals, and ancient seas, life took hold. Not in a sudden spark, but in slow chemistry that forgot it was lifeless. Molecules organized, reactions stabilized, and eventually, cells began to divide. This planet didn't just allow life, it invited it. In the stillness of early Earth, where lightning lit up volcanic skies and oceans simmered with raw ingredients, something extraordinary began to stir, not yet alive, but no longer simply inert. From the primordial soup, simple molecules linked and folded into complex chains. Fatty acids formed fragile membranes, creating tiny bubbles in water, protocells, capable of holding the chaos of chemistry within a boundary. These were not life as we know it, but the precursors to all living things. Then came the spark of replication. Some molecules, like RNA, began to copy themselves, imperfectly. These mistakes, mutations, brought forth variation. And with variation, came selection. Chemistry had learned to evolve. What followed was a slow but relentless unfolding. From the microscopic to the magnificent. Single-celled organisms ruled for eons, learning to photosynthesize, to respire, to cooperate. Over time, some cells joined forces, giving rise to multicellular life, to animals, to ecosystems, to the vast, breathing web of biology. And at the far end of this chain reaction, after fish, after reptiles, after mammals, stood humans, gazing backward, trying to trace the faint thread from pond to consciousness. Life, it seems, was not sparked by magic, but woven step by step, mutation by mutation, from the very fabric of the universe itself. What is consciousness? It's not just life, it's life that knows it's alive. Inside your skull, billions of neurons whisper to one another in electric pulses. They are made of atoms, the same carbon, oxygen, and nitrogen once born inside dying stars. And yet somehow these atoms feel. They remember, they dream, they love. Your thoughts are chemistry. Your memories, patterns of proteins. Your emotions, waves of neurotransmitters carried across fragile synapses. And still, from this orchestra of matter, a mystery emerges. The sense of I. Your brain is the universe reflecting on itself. A bundle of stardust that woke up. To be human is not just to survive. It is to ask why we exist. To search for purpose in a sky of silence. To look at galaxies and find in them the shape of our own minds. Strangely enough, the structure of the cosmos echoes the architecture of the brain. Neurons branch like spiral arms. Clusters of galaxies mimic neural networks. Our eyes, born from cells, now scan the stars that forged our very blood. Our heart beats, steady, rhythmic, like the pulse of a distant quasar. We are atoms, with questions. We are the only species, as far as we know, that can name the stars, and wonder if someone is staring back. There's a quiet irony in the fact that we, made of dust from long-dead stars, now build machines to gaze back at the sky, in search of ourselves. We crafted telescopes like the James Webb Space Telescope not merely to see deeper into space, but deeper into our own origins. Every mirror that unfolds in space reflects a question. Who are we? And why are we here? Across deserts and mountaintops, we erect observatories. Across oceans of time, we send out robotic messengers. We listen for signals, map cosmic background radiation, and simulate the birth of galaxies, all to glimpse something of ourselves in the fabric of the cosmos. Because consciousness is curious. Because to be human is to yearn. We ache to know what came before us and what will come after. And so we ask, is this all there is? Or is there more, out there or within? Perhaps the next chapter belongs to artificial intelligence, minds we create that might one day outpace us. Perhaps humanity will stretch its reach beyond Earth, riding light sails to nearby stars. Perhaps our sun will swell and burn away all that we've known, and still, a trace of us might remain, in data, in stories, in drifting artifacts. We are a brief spark in a vast timeline, a whisper in an ocean of silence. But we are a meaningful whisper, because we ask the question, and maybe that's the answer. Everything in you was once inside a star. We return to the image of Earth, silent, suspended in the vastness of space. A fragile sphere wrapped in a thin veil of blue, the only known cradle of consciousness. You, a spark of awareness, born from cosmic collisions and ancient dust. Your breath, your thoughts, your heartbeat, are echoes of stars that lived and died long before the Earth was born. Through us, the universe gazes at itself. It listens through our ears, feels through our emotions, dreams through our questions. Maybe what makes us human isn't just biology or thought. Maybe it's the longing to understand, to belong, to matter. We are not separate from the cosmos. We are its continuation, its memory, its fleeting moment of awareness. What makes us human? Maybe the answer is written in the stars.